So if you check this column, and this column, you will have only 1 0. You will not have 2 0, for example this column or this column, because 2 0 at the same time is impossible, because we don't have any condition that A equal to B and at the same time, for example, A is less than B or A is bigger than B. It is impossible. Okay, so when you have this truth table, you should summarize this truth table. This is again that truth table in different color. Here, as you know, you should use the kernel map. Okay, because if you wanna design this circuit, it is so big and crowded circuit, and you cannot find your input and output and gate easily. Okay, so that's why we should use the kernel map to summarize this truth table to a function. We can use the kernel map. Okay, I'm quite sure that in your lecture you found out how to use kernel map. Okay, this is the kernel map. How many input you have? 4 input you have. That's why your kernel map will be like this: B0 and B1, A0 and A1, and you design your kernel map and find the 1 in the kernel map. And also you know that how many output we have: 1, 2 and 3. Okay, so how many kernel map we need? 1. This is for this output. This kernel map is for this output, equal to B, and this kernel map is for A less than B for this output. Okay, so as we have 3 outputs, so we need 3 kernel map to summarize our function. When we have truth table, and after that from this truth table we shape our kernel map, we will reach to our function. The function is in your lab sheet. I provided for you. This is the output of that kernel map. You use AND, so we need AND gate, we need OR gate, we need XOR, we need I don't know, NOT. This prime stands for NOT. And also you can see you have 1 output, 2 output, 3 output, and how many input? 4 input. Okay, I did this circuit here. This is the circuit. As you see here, you have 1, 2, 3 and 4 input, and also you have 3 output. It stands for E, it stands for G, and it stands for L. Okay, and this is XOR and OR NOT gate. I designed this circuit based on this function, so it is easy. I did it for you. And as you know, like a previous lab sheet, you just use the compilation or go from here. Okay, I don't want to waste our time with this compilation, and we will go to our simulation. I just want to show you the simulation file, because this is your third lab session, and I'm quite sure that you know how to simulate, how to compile, and just I want to show you the output simulation file. The simulation file is this one. Don't panic about lab 4 name. This is just the name. I did it. This is your output. This is the output of that file. Actually, let me check. I think my compilation is finished. Yes, my compilation is finished 100% here. You can see here, and also again we have 12 warning. It doesn't matter. And for simulation, this is your circuit. For simulation, you just go to int file, new, again in the